In a world where finding the best professors is the toughest task besides calculating time complexity, are you tired of spending numerous hours searching Rate My Professor ratings for the best instructor? Look no further than our very own Rate My Professor Recommender, brought to you by Antonio Villarreal,
Taise Miyazumi, and
Yash Hegde. This program helps decrease the numerous Google searches required to traverse the Rate My Professor site by compiling the data into a more easily accessible format. Utilizing the professor's name, Rate My Professor ID, university, or department can enable for smoother searches and provide information on some of the best professors at the top universities and FSU. We have 8 main options for users to choose from that use a hash table and a binary search tree in unison to compare the time taken for getting results. The first 4 options utilize unique identifiers to find specific professors. Note that the time taken for hash tables is generally shorter than that of a BST. Menu option 1 searches for a professor in all universities by their first name. For example, if we type in Amanpreet, we get the information of every professor with this first name and return their corresponding information. Next, we have menu option 2, which searches for a professor in all universities by their last name and returns their corresponding information. For example, if we type in Fox, we get the information of every professor with this last name. The next menu option searches for every professor with the first and last name and returns their corresponding information. For example, if we type in Lisha Zhou, we get the information of every professor with this full name. There might be a case where we only have a professor's unique Rate My Professor ID. Thus, we would type in their ID and get their corresponding information. For example, if we type in an ID, we get the professor's name and their corresponding information.
In addition, we have options 5 and 6, which focus on using specific university identifiers to find all professors at that university. Option 5 utilizes the university name to search for the entire directory of professors. For example, if we select FIU or Florida International University and search, we can find all of the professors that work at FIU. Keep in mind that the BST is stored by ABC order by first name, and the hash table has it stored by last name. Option 6 is very similar to option 5, as it searches for the university by ID instead of name. So for example, to search for the University of Florida, we can use the code 1100 and get the entire list of professors that work at the University of Florida. Keep in mind the differences in time taken between the 2 data structures displayed in the program.
finally, for the last 2 options, we make use of a rank function to store the rank of the professor in the university and department. In our algorithm, we found the perfect balance between the number of ratings and the overall rating of a professor to calculate a score for each professor. For our first option, we search for the highest rated professor in the university. The top 10 professors of the university based on rank function is displayed. So for example, here we will search for Georgia Institute of Technology, which are returned with the best professors regardless of their department. These lists are ranked from highest to lowest rank, so George will be the highest rank. Next, the last option, we search for the highest rated professor in a certain university in a certain department. So for example, University of Florida, if we search up computer science, we get the top 10 recommended professors in University of Florida in the Department of Computer Science. If we change this to chemistry, we get the top 10 professors ranked from highest to lowest in the chemistry department at University of Florida.